What up? It's time for Rapping the Code, day 11. Today, we're going to do some dynamical programming. For part 1, they tell us that we've noticed a strange set of physics-defying stones. They tell us each stone has a number engraved on it, and every time you blink, the stones change. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. So if the stone is engraved with the number 0, it's replaced by a stone engraved with the number 1. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. And so one thing to keep in mind is that when we do that split, we don't keep the zeros that might be in the front, right? So if I split, I end up getting 0, 1 on this side, then I'll just put 1 on the stone. And they tell us that no matter how the stones change, their order is preserved. So they walk us through an example here. They show us these 2 stones. This stone isn't a 0, and it doesn't have an even number of digits, and so it gets multiplied by 2024. And this stone does have an even number of digits, so it gets split into 2 new stones with a 1 and a 7, and so on. And so they ask us, how many stones will you have after blinking 25 times? Let's parse our input. This is so small that you could probably just put it in a list yourself, but parsing it also won't be difficult. Parsing the input will be pretty straightforward, right? We can just read the whole file, make sure we get rid of any new lines that might be at the end, and then we can split it by white space and convert it into integers, right? So I'm going to say stones equals tuple of map of int, so that it'll cast everything that I split, and I'm going to read the whole file, get rid of any new lines, and then split it. And so now if I print stones, we should get the expected list of numbers. So how can we actually go about solving this? Well, one thing to notice is that once a stone actually splits, we basically don't care about any of the other stones again. Each operation only is performed on a single stone, and the order of the stones wouldn't even matter, right? So what we could do is we could just simulate the 25 blinks for each stone and then add up how many stones are left over. And we don't even have to worry about all the other stones. We can just do it one by one. So now to implement that, right, I'm going to make a function called getNumStones, and it's going to take in a given stone and the remaining number of blinks, and it's going to tell me how many stones that will end up creating, right? So I'm going to define my getNumStones, and it's going to take in a stone and the remaining blinks, and remaining blinks is going to have a default value of 25 because that's the value they asked us for in the problem, right? And so if there aren't any remaining blinks, then we'll just return 1 because there's only the 1 stone that we were given. Otherwise, we should try going through the rules in order and returning the resulting number of stones, right? So if the stone was equal to 0, we should replace the stone with 1 and then see how many that would create, right? So I'm going to return getNumStones of 1 and then remaining blinks minus 1. Otherwise, I should check if there's an even number of digits, right? So to do that, I'll convert the stone number into a string, and then I'll check if it has an even number of digits, and I can split into left and right half, right? So I'm going to say my stone string equals stir a stone, and I'm going to say half, and the remainder is div mod of length of stone string and 2. And so what div mod will do is it'll put the result of the division in half, and it'll put the remainder of the division in rem. And so I can check if there is a remainder, that means that the length of stone string was odd. And so I should multiply it by 2024, right? So I'll return the number of stones when I get numStones of stone times 2024. And I take 1 away from my remaining blinks. Otherwise, it actually was even, and I should split it into left and right halves, and then call getNumStones on each of those and add it together, right? So I'm going to say left and right equals stone stir up to half and stone stir after half. And then I'm going to return get num stones of int of left with remaining blinks -1. So I'm gonna actually I should save this in its own variable, right? I'm gonna say num left equals this, and then I'm gonna do the same thing, and I'm gonna replace all my lefts with a right. And then I'll return how many I get from both. And so this way we've covered all the cases, right? If we don't have any blinks remaining, we have one stone. If the stone has a value of 0, we replace it with 1. If the stone has an even length, then we split it into left and right halves, and the conversion into int gets rid of any leading zeros. Otherwise, we multiply by 2024, and we're done. So now to get the total number, I can just return the sum of get num stones of stone for each stone in our original stones. And so now if I run this part 1, we should see what our result is. We get 199,753, which was the correct answer for part 1. Part 2 is super short. They just ask us how many stones will we have after blinking a total of 75 times. This should be super easy, right? We should be able to just take part 1 and change the 25 to a 75. Let's try running it. Oh man, it's taken a while. Let's take a closer look at our function again. When we do these recursive calls, we actually end up making big branches, and the runtime of our function can grow exponentially. And so as remaining blinks gets larger, the runtime can get really long. Let's look at our example again and see if we can sort of glean anything from it. If we look here, we see this 1 gets multiplied by 2024, and then 2024 gets split into 20 and 24. And then each of these gets split into 2, 0, 2, and 4 again. Then this 0 turns into a 1 again. And then this 1 gets multiplied by 2024. We've seen this before. These numbers will end up splitting and forming cycles, and we'll end up repeating a lot of computation. So maybe we can cut down on our runtime if we cache answers for stones that we've seen before. Luckily in Python, there's a really easy way to do that. We can just use the cache decorator from functools module. Let's see if that helped us out. Bam, we got a result instantly, and it was the correct one for part 2. Thanks for watching. This was a pretty short one. I hope it was informative. I'll make sure to post my solutions on GitHub. And if you want to solve LeetCode with me on the daily, I'll have my Discord server link in the description down below as well. And yeah, have a good one.